morning, good afternoon, good evening, whatever the case may be. We are back and better than ever, and today we are going to use the Pythagorean theorem to solve some problems. As we listen to Men at Work and the great song Be Good Johnny, we will get back to them in a second. Not in a second, at the end of this lesson. Classic song. Let's get to it, shall we? Okay, first couple of things. Special geometric fingers. Whoa, geometric figures. We've got your rectangle. We got the diagonal. All four right angles. You all know all about the rectangles. And a square and a rhombus. A rhombus is a quadrilateral where all four sides are equal. The biggie is that in a square and a rhombus, the diagonals bisect one another and form right angles right here. They intersect at right angles. This side equals this side equals this side. And in isosceles and equilateral triangles, if you drop an altitude from the vertex, in this case for an isosceles, it has to be the vertex that is made by the two equal sides. An altitude is going to be perpendicular, and it divides the base into two congruent sides. Just wanted to review that. So a rhombus has diagonals of length 6 and 8 centimeters. Find the lengths of its sides. So you would have to draw a picture. I already drew one here. And I'm going to label it. So like we just said, a rhombus, the diagonals intersect at right angles. So we have a right angle symbol there. And they tell me that the diagonals are of length 8 right here. So from here to here is 8, and from here to here is 6, right? Well, we know that they also bisect each other, so this segment equals this segment, and this segment equals this segment. So from here to here is 3, and from here to here is 4. Half of 6 is 3, half of 8 is 4. Find the lengths of its sides. Well, all the sides in a rhombus are equal. That's what makes a rhombus a rhombus. Just doing the marks there. So if I find the length of one of the sides, I found them all. And of course, we have a right triangle here. Hopefully you recognize it as a very common right triangle, which is a 3, 4, 5 right triangle. In other words, if I didn't know that and I said x, well, x squared would equal 3 squared plus 4 squared. X squared equals 25. X equals the square root of 25, which is equal to 5. And I did not put plus or minus there because this is a length, and length cannot be negative. By the way, just so you know, when you are simply finding the square root of a number, you just have to find it. Square root of 64, that is equal to 8. When you're solving x squared equals 64, then you're saying, what are the possible answers? Well, the possible answers in this equation would be plus or minus 8. But if you're just finding the square root of 64 that's not part of an equation, square root of 64 is 8, or the square root of anything else. Back to this, I would expect you to see a right triangle that had legs of length 3 and 4 and not have to work this out, to immediately recognize this as a 3, 4, 5 right triangle and immediately know that the hypotenuse is of length 5. All right, next example. An equilateral triangle has sides of length 6 centimeters. Find its area. Well, equilateral triangle is a little easier to sketch, so I didn't do that ahead of time. Easier said than done there, as I messed that up. Okay, that's a bad side. I don't care. So we have a side of length 6. So if I drop a perpendicular right here, I know from here to here is 3. And I know that this side, of course I choose the bad side, this side is also of length 6. It's equilateral. And this is going to be my height. I'll call that x. Now, perhaps I should have started with this, but we know that the area of a triangle is base times height divided by 2, or 1/2 base times height. So we already know the base is 6, so I need the height, and then I'll divide it by 2. So clearly x squared plus 3 squared equals 6 squared. X squared plus 9 equals 36. X squared is equal to 27. So x equals root 27. Okay. So then we substitute that back in there. So it's going to be equal to 6 root 27 over 2, which is 3 root 27. Now that is an exact answer. A decimal approximation would be about 15.6. I prefer an exact answer. And in fact, this can be simplified. Hopefully you remember how to do that real quick. 27 is 9 times 3. The square root of 9 is 3, so this becomes this 3 times the square root of 9 is 3, and this 3 has to stay in because the 3 is not a perfect square, the 9 is, so this becomes 9 root 3. Okay, I think this is the last example we're going to do. We're going to talk about true bearings. Now these are nautical, this is a nautical term, true bearings, for the most part. I shouldn't say nautical, navigational, but nautical, boats do it a lot. But what you want to know about true bearings, or the bearing of something, it is degrees clockwise from north. So a bearing of 72 degrees, you start with a ray pointing north and rotate clockwise, and clockwise is this way, of course, 72 degrees, and then that is the bearing. It's a bearing of 72 degrees. So let's think of a bearing of 100 degrees. I'll just do that real quick. Start with north, and then it's kind of nice to do this to get your south, your east, and your east and your west. South, east, west. I never write those, but I will now. So 100 degrees, if I start rotating this way, it's going to go past 90 at east, maybe about right there. So that would be a bearing of 100 degrees. So that's how it works. A true bearing is always written using 3 digits. So you might see something as 072 degrees. Okay, so let's do this one. A helicopter travels from base station S on a true bearing of 74 degrees for 112 kilometers to outpost A. It then travels 134 kilometers on a true bearing of 164 degrees to outpost B. How far is outpost B from base station S? Well, we got to draw all that. A helicopter travels from base station S on a true bearing of 74 degrees for 112 kilometers to outpost A. Let's draw that. So I'll put S, doesn't really matter where I start. I'm going to say this is outpost S. And I need to draw a ray with a bearing of 74 degrees. And again, this is very helpful to do this. I'm going to draw north, and then some dotted lines maybe to draw east, west, and south. And again, this is bearing S. So 74 degrees, remember east is going to be 90, maybe like that. So I'm going to say there, and it's 112 kilometers, and it is to outpost A. We'll call that outpost A. So we've taken care of this part. So from A, it then travels 134 kilometers on a true bearing of 164 degrees. So now we have to do this all over. Okay, here's north. And just before we move forward, a ray drawn north is parallel to another ray drawn north. They're both going north. Doesn't that make sense? Okay, and put in my little dotted lines for east, west, and south. Let's see, for 164 degrees, well, again, bearing is clockwise starting at north. So here's 90, all the way is 180. So maybe that's 164 degrees. Okay, so I'll draw that. Oops, a little bit of a mess there. Okay, and that is to outpost B. And this is, what was it, 134? Very good. Okay, and then they say, how far is outpost B from S? So I'll draw that, and that is my X. Well, how in the world are we going to solve this? Well, we know this is 74 degrees. We know that this is 164 degrees. Okay. Well, if this is 74 degrees and north is parallel to north and is parallel to going south as well, we have alternate interior angles, so this is 74 degrees. And also, we know from north all the way around to south is 180 degrees. Now I'm going to undo that so because I don't want our picture to get messy, but that's 180 degrees. And from here to here is 164, so that means this angle must be 16 degrees. And holy smokes, what's 74 plus 16? I believe, kids, it is 90 degrees. So what we have here is a right triangle. What? So I can find this distance using my good friend Pythagoras. X squared is equal to 112 squared plus 134 squared. X squared is equal to 30,500. X is equal to the square root of 30,500. Again, no need to do plus or minus because distance is not negative. And if you put that in your calculator, we're going to say X is approximately equal to 175 kilometers. So it's about 175 kilometers away from outpost S, that is outpost B. Okay, that is it. That is all I have. Hope you enjoyed it. I know that I did. And with that, I am out. Every golden rule gets taught by the teacher.